So we're here talking about decision making with multiple objectives. And in this video, we're going to focus on one approach where you take all the objectives and you convert them into one of the metrics. To remind you of the scenario that we're in, you've got a bunch of options, which we could call alternatives. You have multiple things that matter to you, which can be called objectives or metrics or attributes or several other things. And the question is, which alternative should you choose? Now, for this video, we're going to have a scenario of selecting an apartment based on two objectives, monthly rent and monthly commute time. And here are the four apartments that we're looking at and how much they cost in rent and how much monthly commute time you would have. Now, the trouble here is that rent is in dollars and monthly commute time is in hours. So you can't just add those two up. They're different units. You have to do something to make them commensurate with each other. So in our case, in this video, we're looking at situations where you can trade off success in one metric for a weakness in another. For instance, something that has a really long commute time, you might be willing to consider it if it's really inexpensive. These are called compensatory approaches, and a couple ways to think about it. One is that you can convert all of the different metrics, in this case, monthly cost and monthly commute time, into just one of those metrics. Second thing, or second way to do it, is to convert all the data, all the metrics, into a dimensionless unit. We'll look at each of these over a few videos, but right now we're going to look at this idea of converting all the data to its equivalence in a single metric. Back to our example where we have four apartments, monthly rent and monthly commute time is what we're using to compare these apartments. We're going to create a new metric called total monthly cost, where we put both of these metrics into dollars terms in terms of how much they would cost us each month. This total monthly cost is going to be defined as the monthly commute time multiplied by the cost per hour of commute time plus the monthly rent. Let's go through and see what this might look like for a particular example of how much our time is worth during our commuting. So what if our time is worth $100 an hour? We come down to this table below, and the only change here is that monthly commute time in hours has been replaced with monthly commute cost in dollars. And we just need to multiply each one of our commute times in hours by $100 per hour. So I brought out the supercomputers for this, and we see that the 20-hour commute time is $2,000 of monthly cost if our time is worth $100 an hour. We add these up, and we can see that the total monthly cost of all four of these apartments happens to be $3,500. So we're completely indifferent between these four apartments based on these two metrics. All right, so what if your time is worth $200 an hour? How does that change your preferences for these four apartments? Well, we can just calculate a new dollar equivalent for each one of our monthly commute times. And now our 20 hours has become $4,000 because it's worth $200 an hour. When we add these up, the rent and the monthly commute costs, we can see that in the total monthly cost, our best apartment now is apartment D. Now that shouldn't really totally surprise us because we've just said we went from $100 an hour to $200 an hour. That means that our commute time has become more valuable to us. We're paying more per hour of commute time. At $100 an hour, these four apartments were totally equivalent. Now that commute time is worth more, you would imagine the apartment with the shortest commute time would become more valuable. And in fact, that's exactly what happened. Apartment D had the shortest commute time, and now it's the most preferred one because it has the lowest cost. It can be helpful to view this graphically. And I'm just going to start by putting our 4 apartments on this XY graph, where the vertical axis is commute time and the horizontal axis is rent in thousands of dollars. So you can see that at $1,500 and 20 hours of commute time, apartment A is here, apartment B, apartment C, and apartment D. All right. What if your time is worth $100 an hour? How does that represent itself graphically? Well, I'm going to start by putting this line here and putting $3,500 on it. And then we'll start talking about what this line means. So this line is, anything on this line is equally preferred in terms of rent and monthly commute time if your time is worth $100 an hour. And you can see, let's take for apartment D, we have $3,000 of rent and we have 5 hours at $500 an hour. So it's $3,500 for apartment D. If we go to apartment C, right, one up from that one, our rent is 2,500. We're going to add 10 hours times $100 an hour. So that's also equals 3,500. And in fact, anywhere on this line is indeed $3,500. One of the properties of this line, if we come up here to the top left and look at it, is let's just take from here to here. Let's measure the slope of this line. We have 5 hours difference, and we also have $500 difference. So you can see the slope of the line is $100 per hour. That's all the slope is defined by, is that trade-off, right, between commute time and monthly cost. If we continue to look at different places on this graph, let me come down here to this line I just drew. Here, if I look at this point, that means a apartment with a hypothetical apartment with 0 commute hours and the rent is $2,500. A little bit up from here, this is a hypothetical apartment. The rent is $2,000 and the commute time is 5 hours. So that's $500 worth of commute time. So 2,500. This line is in fact an ISO preference line valued at $2,500. So it's anything on this line is more preferred than anything on that initial line that is worth $3,500. And we could do this throughout the graph. Here's the line for $4,500 if your rent and commute time were added up and you're assuming $100 an hour. That's any apartment on that new line that says 4,500 would be equivalent to each other and they would all be worth 4,500. And you could have this whole gradient going across this graph. As you move in this direction, your apartments are becoming less and less expensive or more and more preferred. So essentially, whichever apartment is further down in that direction is the most preferred one. In this case, of course, all 4 are equally preferred because they're all on the same ISO preference line. But what if your time's worth $200 an hour? What happens to this graph? At $200 an hour, we're going to start down here on the very bottom axis where our commute time is 0. If our commute time is 0, then our monthly cost is totally based on rent. And this point down here is still going to be $3,500, whether the value of your time is $200, $500, $100 an hour. This point I just drew on the axis is always going to be $3,500. Now at $200 per hour, where would other points be that are worth $3,500 on this graph? Well, let's see. If your rent was 2,500, how high up, how much commute time would you have to total out at 3,500 total monthly cost? Well, it would be an extra $1,000 to get to 3,500. And to get that extra $1,000, you only need 5 commute hours because your time is now worth $200 an hour. So it would be right here. That would also be valued at $3,500 if your time is worth $200 an hour. And we can continue that on and see that our ISO preference line, when our commute time to rent is at $200 an hour, is represented by this flatter line. And we could look at it and see that the slope indeed now is for every $1,000. It is 5 hours, so that's $200 per hour. We can keep making other ISO preference lines at $200 an hour, and this is what they would look like, all in parallel, and getting more expensive as I just drew them, or from up here down to here, getting less expensive. And so now our 4 apartments are on 4 different ISO preference lines, and the one that is the furthest down to the left, because we're trying to minimize our cost, is this one, apartment D, just as we found it before in the table. Let me ask you 2 more questions. What if only time matters, or what if only rent matters? We're kind of returning it to a single objective. Well, notice from $100 an hour to $200 an hour, our ISO preference line of where we're equally happy with all the apartments on those lines has gotten flatter. The slope has gotten flatter because time has become more valuable. At an extreme of value, time is the only thing that matters. And so if you were to draw the ISO preference line when only time mattered, it would be horizontal. And anything that was lower, all of our ISO preference lines when only time mattered might look like this, moving up, and anything lower would be better. And in fact, apartment D would be the best in that case. What if only rent matters? If only rent matters, our ISO preference line is vertical, and you could think about the gradient being like this, and anything in this direction is better. In that case, it would be apartment A up here, which has the lowest rent. So in summary, this is a compensatory approach because you're trading off one amount of a variable metric for another. And this is one where we convert all the metrics into one of the metrics to start, which we had rent was a cost. So we just converted time into cost. This is totally valid. It's a great way to work certain decisions, particularly when that conversion makes sense to the decision makers. In this example, it makes really clear the trade-off of how many dollars you're willing to spend per 1 hour of commute time, the value of your time. This trade-off is called the marginal rate of substitution. Take note of that name. It's going to come back to us in other times because the marginal rate of substitution is just a way to model someone's preferences, how much of one thing they're willing to trade off for another. And as we've done it here, it's a linear way to model preferences. Go back to the graph, and you can see how all of those lines were indeed lines, were linear. Now, while we converted everything into cost for this case, many people do take a different approach to modeling compensatory decisions with multiple objectives, an approach where all the metrics are converted to a dimensionless score. And that's what we'll do and talk about in our next video.